Hey guys, we're back for another one. Today we're going to be learning about exponents, really exponent skills specific for the SAT. So let's get started. The first few questions we have are just a little bit of a warm-up. Remember that through x to the 7th times x to the 5th through multiplication, what do? We add. Really, it's going to become x to the 12th. Through division, what do? Through division, you subtract. It's x to the 2nd. Power of a power, x to the 7th to the 5th, what do? We multiply, it's x to the 35th. What about part D? Part D says x to the negative 7th. What do we do with x to the negative 7th? A negative power sends things to the bottom. Really, it's going to be 1 over x to the 7th. Again, a negative exponent in the top sends it to the bottom. Part E is a rational exponent, x to the 7/5. That's going to become 5th root of x to the 7. The best way to remember that is x to the 7 stays as x to the 7, whereas this guy right here, the divided by 5, that's going to become your denominator. The denominator is the power of the root. Let's take a look at part F. And for part F, really, we're going to look back at part D, because what did I say? I said a negative power in the top sends it to the bottom. Therefore, what do you think a negative power in the bottom is going to send it to? To the top. Really good. Again, a negative power in the top is going to send it to the bottom. A negative power in the bottom is going to send it to the top. So really, they just swap like that. Y to the 5th over x to the 7th. Let's move over here for letter G and H. These are two of the harder examples, but not too bad. Right here, 3x squared to the 3rd. A lot of my students get this question wrong. Please don't. Understanding that 3 to the 3rd, what is 3 to the 3rd? Of course, 27. And then what's x to the 2nd to the 3rd? Again, x to the 2nd to the 3rd, that's going to be multiplication, x to the 6th. Now, the last case is really the hardest case, and it shows up on the SAT all the time. I call it disguise. Really, whenever you have a number, a fishy number like 9, a fishy number like 27, a juicy number, what is that telling you, or what does that want us to do? Well, essentially that it's in disguise. 9 isn't really 9. 9 is actually 3 to the 2nd to the 2x plus 1. What about 27? 27 isn't really 27. It's actually 3 to the 3rd to the negative 5x. Okay, well now what? Well, now you can understand that we have power of a power, power of a power. So those are just going to multiply. Really, I have 3 to the 4x plus 2 equals 3 to the negative 15x. And at this point, you can understand that, 3 to the this equals 3 to the that. You can just set them equal to each other. 4x plus 2 equals negative 15x. When you go to solve this, it's not too bad. You have 2 equals negative 19x. X equals 2 over negative 19. So that is the idea of disguise. Again, how did I do that? I put them in the same base. I put them in a similar base. 3 to the 2nd and 3 to the 3rd. That's really the only way to do this question without a calculator. All right, so let's start applying these skills. Coming over here, these are all real SAT questions. This is SAT non-calculator. What does it want us to do? Oh, it just wants us to rewrite this. A to the 2/3. A to the 2/3 is really what? Well, what did we say? We said that this will stay, so it'll be a to the 2nd, but then the denominator becomes the power of the root. The answer is D. How easy is that? Pretty easy there. That just took us seconds. Let's come over here for a harder example. Take a look at this one. This one is a bit tougher, really a number 18 on an SAT non-calc, but a few of our rules apply here. What did we say? A negative power in the top sends it to the bottom. A negative power in the bottom sends it to the top. Oh, that's really useful. Really, so far I have y to the 1, y to the 1/2, all over x to the 2nd, x to the 1/3. Now what? Well, now especially using the answer choices to kind of guide us here, what can we see? Well, we can see that, wait a second, y to the 1/2, didn't we talk about that? Isn't that really something special? Isn't that really the second root of y to the 1? I think so. What about this one? Isn't that really cube root of x to the 1? I think so. So really at the end of the day, when you rewrite that, you really have y square root y, x squared cube root x. Really, I really like answer choice D. And that's it for this question. It looks a lot harder than it is. Again, what skills did we employ here? We sent this negative exponent to the bottom, and we sent this negative exponent in the bottom to the top. They just swapped right like that. From here, we also understood that, oh, that's not just a rational exponent. You can actually put that into a radical, into a square root. Just like this one, we can put into a cube root. So those are all pretty good questions, not too bad, but I want to now take you to two really hard questions. Down here are my challenge questions of the day. These are both SAT non-calculator questions, and they're both extremely difficult, I think. If you want to take a shot at either of them, please pause the video. But of course, if you want to just watch along, this is how I see it. First of all, I understand that 8 and 2, those are really juicy numbers, and I don't really know what else to do, but I wonder if I could use my idea of disguise here. Really, is 8 really 8? No, I think it's in disguise. Really, 8 is actually 2 to the 3rd to the x, and this will be 2 to the y. From here, power of a power will become 2 to the 3x all over 2 to the y. And now, through division, remember what did we say? Through division is subtraction. You have 2 to the 3x minus y. And at that point, well, wait a second, what is 3x minus y? 3x minus y is actually 12. What's my final answer? 2 to the 12th. I really like answer choice A. That's a really tough question. Again, what skill unlocked that for me? Really the idea of disguise, the idea that 8 isn't really 8. It was actually 2 to the 3rd all along. All right. If you have any questions on this question, obviously leave them in the comments and I will get back to you. But let's come over here for this question. This is our last question of the day, really another SAT non-calculator question and another tough one. If you'd like to give it a shot, please pause the video there. But of course, if you want to watch along, feel free. The idea behind this question is this. First of all, through division, what did we say? Through division, it's subtraction. X to the a squared minus b squared equals x to the 16th. From here, we can understand, well, wait a second, I have alarms going off in my head right here. I have alarms going off in my head because what is a squared minus b squared? Oh, that's a difference of squares. This actually becomes x to the a plus b. A minus b equals x to the 16th. Again, this is a difference of squares, really a factoring skill. The factoring skill that makes this a plus b times a minus b. From here, I'm almost done, I promise. Really, the last step is understanding that a plus b is equal to 2. And if a plus b is equal to 2, what must a minus b be? Well, 2 times a minus b equals 16. Really, what must a minus b be? It must be 8. Why? Because if this were 8, 2 times 8 does get you to 16. Again, a minus b must be 8. Another tough one from the SAT non-calculator, but please make sure that you can understand these questions and get them. And if you have any questions, like I said, please post them in the comments down below, and I will make sure to get back to you. I'll see you guys on the next one.